lesson with Chapter 2, Bohr's Atomic. Okay, before we start, right, I want to introduce few characters with you all. First is Miss Elaine, chemistry teacher. And then this is Mark, naughty Mark. And then this is handsome Jack. And this is Madam Suzanne, art teacher. So, let's try to investigate a question. Electron in an atom may occupy ground state or excited state. Actually, what is ground state? What is excited state? So now we try to use some analogy to explain this concept. Just imagine there are two students, Mark and Jack, having class before lunchtime. How do they feel? So could you relate this situation to an electron in a ground state? Then students are eating their food at cafe. Do they gain energy or lose energy? Later they are playing football in the field. So what do you think of their condition now? After the games, they attend another class. What happens now? Let's start the story with okay, good morning. Today we are going to learn ground state and excited state. Miss, am I in ground state? I am hungry. During recess time, the first thing Mark and Jack wanted to do was go to cafe. Mark, today French fries so crispy and delicious. Yes, my sandwich also yummy. Later we can go to play football. After eating, they are so enjoying at the field to play football. Jack and Mark, two of you why so late come to my class? Your face seems like very tired. Yes, Miss Suzanne, I am very hungry and exhausted. Yes, Miss Suzanne, now we are at ground state. See, both of them are so clever. Apply the ground state and excited concept while explain to Miss Suzanne for their condition. So how to define ground state? Ground state is an electron possesses the lowest energy state in an atom, and this state is the most stable state. While for excited state is electron possesses energy higher than the ground state and it is unstable. So the state actually is referred to the energy level. So for example, n equal to 1 is the energy level equal to 1. N equal to 2 is the energy level associated with a specific orbit at n equal to 2. So here is the nucleus. According to Bohr's atomic structure, there are 4 postulates. So postulate 1, electron move in a circular orbit about the nucleus. So this is the circular orbit. The electron move around. While it moves around, right, it does not radiate or absorb any energy. Postulate 2, the energy of an electron in the hydrogen is quantized, meaning that the electron has only a fixed set of around orbit, means while it's n equal to 1, then it's n equal to 1. And this state is also called a stationary state. Postulate 3, at ordinary condition, right, the electron is at ground state, lowest level. When energy is supplied, electron absorb the energy and is promoted from a lower energy level to a higher one. So like Jack and Mark, after they're having their lunch, they have energy because food provide energy. So now they're excited and playing football at the field. Okay, then postulate 4, electron at its excited state is unstable. It will fall back to a lower energy level and release a specific amount of energy in the form of light or photon. Like Mark and Jack, after playing football at the field, right, they consume the energy. Okay, so the potential energy change to kinetic energy. After change to kinetic energy, they have no more energy, so then back to ground state. So the energy of photon equal to the energy difference between the levels. So we are going to apply the calculation part for the postulate 1 and postulate 4. Just now we learned about 4 postulates of Bohr's atomic model. But there are few weaknesses of Bohr's atomic model. So these are the 4 weaknesses. So the first one, okay, it cannot explain the emission spectrum with more than 1 electron for an atom or ion. So from starting we keep on saying this model using hydrogen atom, because hydrogen atom only have 1 electron. So others ion that can explain this model like helium positive, lithium 2 positive. Okay, at the same time it cannot explain the extra life form in the hydrogen spectrum. And then the third one cannot determine the precise location of the electron since electron appear wavelength. So from the starting, Bohr stated the properties of electron is like particles, but actually no. So this Bohr's atomic model unable to explain the dual nature of electron. And then the last one is electrons are restricted to move in a certain distance around the nucleus of an atom. It means n equal to 1, n equal to 2, and so on. But in reality, electron is scattered around. Okay, so it will induce the positive area, and then it will become partially negative, and so on. This one you will learn in detail in chapter 4. So the weakness of Bohr's atomic model is overcome by de Broglie postulate and Higgs-boson uncertainty. So according to de Broglie, proposed that electrons have the properties of matter or particles at the same time can exhibit the properties of wave. So by using this formula, okay, he deduced that the properties are related by the expression of this. Okay, you just need to know this formula, and then the lambda stand for H, mass, and mu stand for. So in order to help you to explain de Broglie postulate. Next is Higgs-boson uncertainty principle. So it is impossible to know simultaneously both the momentum and the position of a particle according to Bohr. So Higgs-boson uncertainty principle try to apply this formula to calculate the momentum and position of the particles. So for de Broglie postulate and Higgs-boson uncertainty principle, you just know what is the story explained about and the formula, and then what is the X, P, H stand for, that is enough. So that's all for today. Don't forget to follow my IG at ChemicomSL. Subscribe, like, and share my YouTube channel ChemicomSL, and follow my Facebook ChemicomShirley. Hope you all learned something. Thank you.